ಹಲೋ ಫ್ರೆಂಡ್ಸ್, ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಕನ್ನಡ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ನಿಮಗೆ ಸ್ವಾಗತ. ಇವತ್ತಿನ ಈ ವಿಡಿಯೋದಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಇಟ್ ಇಸ್ ಅನ್ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಪಾರ್ಟ್. ಸೊ ರೆಗ್ಯುಲೇಷನ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ರಿ. ಅದಾದಮೇಲೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಪೀಕ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸೊ ಪ್ರಾಬ್ಲಮ್ಸ್ ಒಂದು ಸ್ವಲ್ಪ ತೊಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡೋಣ. ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ಈಸ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್. ಫಸ್ಟ್, ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಡೆಫಿನಿಷನ್ ಏನು, ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಅಂದರೆ ಏನು, ವೈ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್, ನಮ್ಮ ಹತ್ರ ನಾರ್ಮಲ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಇದ್ರೂ ನಾವು ಯಾಕೆ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ದ ಫಿಫ್ತ್ ಟಾಪಿಕ್ ಈಸ್ ವಾಟ್ ಆರ್ ದಿ ಅಡ್ವಾಂಟೇಜಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಆಫ್ ಯೂಸಿಂಗ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್. ರೈಟ್, ಇಂದಿನ ಕ್ಲಾಸ್ನಲ್ಲಿ ನಾವೇನೇನು ಮಾತಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ರಿ. ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಇಸ್ ಅ ಸ್ಟಾಟಿಕ್ ಡಿವೈಸ್, ಸ್ಟೆಪ್ ಅಪ್ ಮತ್ತು ಸ್ಟೆಪ್ ಡೌನ್ ಯೂಸ್ ಮಾಡ್ಕೋಬೋದು. ಮತ್ತು ಇಟ್ಸ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ಪವರ್ ಡಿವೈಸ್, ಕಾನ್ಸ್ಟೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡಿವೈಸ್. ಸೊ ಇದೆಲ್ಲ ಸಮ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಇತ್ತು. ದೆನ್ ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಪ್ರೈಮರಿ ವೈಂಡಿಂಗ್, ಸೆಕೆಂಡರಿ ವೈಂಡಿಂಗ್, ರೇಟಿಂಗ್ನ ನೀವು ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀರಾ ಅಂತ ಹೇಳಿದ್ರೆ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ KVA. ರೈಟ್, ಆ್ಯಂಡ್ ಫ್ಯಾರಡೇಸ್ ಲಾ ಈಸ್ ಗಿವನ್ ಬೈ V equals to minus N into d phi by dt, V2 by V1 which is equals to N2 by N1 which is equals to K, voltage transformation ratio, K equals to 0.5 ಇದ್ದರೆ ಲೂಸ್ಲಿ ಕಪಲ್ಡ್, K equals to 1 ಇದ್ದರೆ ಟೈಟ್ಲಿ ಕಪಲ್ಡ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಆಫ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್. ಲಾಸಸ್ 3 ಟೈಪ್ಸ್ ಆಫ್ ಲಾಸ್ ಇದೆ: ಐರನ್ ಲಾಸ್, ಕಾಪರ್ ಲಾಸ್, ಲೀಕೇಜ್ ಲಾಸ್. ಐರನ್ ಲಾಸಲ್ಲಿ ಅಗೇನ್ 2 ವೇರಿಯಂಟ್ಸ್ ಇದೆ. ಯಾವುದ್ಯಾವುದು? ಎಡ್ಡಿ ಕರೆಂಟ್ ಲಾಸ್ ಮತ್ತು ಹಿಸ್ಟರಿಸಿಸ್ ಲಾಸ್. ಅದು ಆದಮೇಲೆ ವಿ ವಾಂಟ್ ಐಡಿಯಲ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್, ಬಟ್ ನಮಗೆ ಪ್ರಾಕ್ಟಿಕಲ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸೇ ಸಿಗುತ್ತೆ. ಸೊ ಕಂಪ್ಯಾರಿಸನ್ ಆಫ್ ಐಡಿಯಲ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಪ್ರಾಕ್ಟಿಕಲ್ಸ್ ವಿ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ಡ್. ಮತ್ತು RMS ವೋಲ್ಟೇಜ್, ಈ ಫಾರ್ಮುಲಾ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅದಾದಮೇಲೆ ಲುಕ್ ಅಟ್ ದ ಥಿಂಗ್ಸ್, ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ರೇಷಿಯೋ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನಾದರೂ ಕೊಟ್ಟವಾಗೆ ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಬೇಸ್ಡ್ ಆನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ರೇಷಿಯೋ. See, network elements will be there on both source side as well as load side. ನನಗೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕೆ ಈಸಿ ಆಗಲಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾನೇನು ಮಾಡ್ತೀನಿ, ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ನು ಸೋರ್ಸ್ ಕಡೆ ಆದರೂ ಪುಷ್ ಮಾಡ್ಬೋದು, ಇಲ್ಲ ಅಂತಂದರೆ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ನು ಲೋಡ್ ಕಡೆ ಆದರೂ ಪುಷ್ ಮಾಡ್ಬೋದು. ಸೊ ಇಫ್ ಐ ಆಮ್ ಸೆಂಡಿಂಗ್ ಲೋಡ್ ಸೈಡ್ ಟು ಸೋರ್ಸ್ ಸೈಡ್ ಡಿವೈಡ್ ಬೈ K², ಸೋರ್ಸ್ ಸೈಡ್ ಟು ಲೋಡ್ ಸೈಡ್ ವಾಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಮಲ್ಟಿಪ್ಲೈ ಬೈ K². ಇದೊಂದು ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಟೆಕ್ನಿಕ್ ಗೊತ್ತಿದ್ರೆ ಸಾಕು. ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಏನು ಹೇಳ್ತೀನಿ, percentage voltage regulation which is given by V no load minus V full load divided by V no load into 100%. Right? Voltage regulation is always positive in the case of lagging power factor, but leading power factor ಅನ್ನೋದು ಬರೋದಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ದೆ. ಬಟ್ ಯಾವಾಗ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ when the load is of capacitance. ಕೆಪಾಸಿಟರ್ ನೀವೇನು ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ ಅಂತಲೇ ಯು ವಿಲ್ ನಾಟ್ ಬಿ ಗೆಟಿಂಗ್ ರೈಟ್. ಸೊ ಯಾವಾಗೆ ಲ್ಯಾಗಿಂಗ್ ಬರುತ್ತೆ, ಯಾವಾಗ ಲೀಡಿಂಗ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀವಿ. ಇನ್ ಅ ಸೀರೀಸ್ ಆಫ್ ವಿಡಿಯೋ ವಿಲ್ ಕಮ್ ಟು ನೋ. ನೆಕ್ಸ್ಟ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಟೆಸ್ಟ್ ಮಾಡ್ತೀರಿ, ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಟೆಸ್ಟ್ ಮಾಡ್ತೀರಿ, ಪೊಲಾರಿಟಿ ಟೆಸ್ಟ್ ಮಾಡ್ತೀರಿ. ದೆನ್ ಸಪೋಸ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ಪ್ರೈಮರಿನಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತಾ? ಎಸ್, 3% to 5% ಆಫ್ ದ ರೇಟೆಡ್ ಕರೆಂಟ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಫ್ಲೋ. ನೆಕ್ಸ್ಟ್ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಟೆಸ್ಟ್, ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ರೆಫರ್ಡ್ ಆಸ್ ಇಂಪಿಡೆನ್ಸ್ ಟೆಸ್ಟ್. ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಕಾಪರ್ ಲಾಸಸ್ ಕಂಡುಹಿಡಿಬೇಕು ಅಂತಂದರೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಟೆಸ್ಟ್. ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಟೆಸ್ಟ್ ಈಸ್ ಫಾರ್ ವಾಟ್? ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಟೆಸ್ಟ್ ಈಸ್ ಫಾರ್ ಕೋರ್ ಲಾಸ್ ಅಥವಾ ಐರನ್ ಲಾಸ್. ಈ ಫಾರ್ಮುಲಾ ನೋಡ್ಕೊಳ್ಳಿ, ಇಂಪಾರ್ಟೆಂಟ್. ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಎಡ್ಡಿ ಕರೆಂಟ್ ಇಟ್ ಈಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ F². ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಹಿಸ್ಟರಿಸಿಸ್ ಲಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ F. Efficiency, this formula is very very important. When efficiency is tending to maximum, when PC equals to X² times of PCU, efficient ಅದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ನಲ್ಲಿ ವಾಟ್ ಈಸ್ ದ ಮೇಜರ್ ಡ್ರಾಬ್ಯಾಕ್? ರೈಟ್, ಮೇಜರ್ ಡ್ರಾಬ್ಯಾಕ್ ಈಸ್ ಐಸೋಲೇಷನ್ ಕಳ್ಕೊಳುತ್ತೆ. ಬಟ್ ಏನು ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಇನ್ಕ್ರೀಸ್ ದ ರೇಟಿಂಗ್, ಎಫಿಷಿಯನ್ಸಿ ನಾವೇನಾದ್ರು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು, ಅವಾಗೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್. ರೈಟ್, ನೆಕ್ಸ್ಟ್ ನಾನು ಆಲ್ರೆಡಿ ಲಾಸಸ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದೀನಿ. ಲಾಸಸ್ ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ 2 ವೇರಿಯಂಟ್ಸ್. ಒನ್ ಈಸ್ ಕೋರ್ ಲಾಸ್ ಆ್ಯಂಡ್ ದ ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ಕಾಪರ್ ಲಾಸ್. ಸಿ, ಕೋರ್ ಲಾಸಲ್ಲಿ ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. Look at over here, you will be having this expression. Core loss ಏನಂತ ಬರುತ್ತೆ? So you will be having eddy current loss, that is some constant multiplied by F². Some constant multiplied by F². So I'm going to take C1 multiplied by F² plus C2 multiplied by F. C2 multiplied by F. So only if I am talking about core loss, so core loss ಅಲ್ಲಿ ನಮ್ಗೆ ಏನೇನು ಬರುತ್ತೆ? which is constant multiplied by F² plus constant multiplied by F. Right? So this is core loss. Right? It is core loss. Core loss is a function of frequency and frequency square. very, very important. Next, per unit system, you should know. In the case of per unit system, say suppose in the source side, if it is 200 volt and in the load side you are getting 400 volts. Next, say suppose input ನಾನು 400 volts ಅಂತ ತಗೊಂಡ್ರೆ blindly you have to write it is 800 volts. ಅಥವಾ source side ಏನಾದರೂ 100 volts ಅಂತ ತಗೊಂಡ್ರೆ blindly you have to write this is 200 volts. So this is referred as per unit system. This is referred as per unit system. Input to output ಹೇಗೆ ವೇರಿ ಆಗುತ್ತೋ in the next case also you are going to consider in the same way. You are going to consider in the same way, right? Next, regulation when you will be having inductive load or you will be having inductance. Next one is, let us talk about capacitance. Let us talk about capacitance. See, what is the basic information? ನಾನು ಏನು ಹೇಳಿದ್ದೀನಿ ನಿಮಗೆ. In the case of inductance, we are going to get a lagging network or a lagging power factor. But in the case of capacitance, we are going to get leading. ಯಾವಾಗ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ provided when you are going to connect a load, right? ಲೋಡ್ ಏನಾದರೂ ಕೆಪಾಸಿಟರ್ ಏನಾದರೂ ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ, ಸೊ ವೆನ್ ಇಟ್ ಈಸ್ ಡಾಮಿನೇಟಿಂಗ್ ಅವಾಗ ಮಾತ್ರ ನಮ್ಗೆ ಲೀಡಿಂಗ್ ಅನ್ನೋದು ಬರುತ್ತೆ. ಸೊ ಹೌ ಕ್ಯಾನ್ ಯು ಡಿಫೈನ್ ದಿಸ್ ರೆಗ್ಯುಲೇಷನ್ ಆರ್ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು zeta r times of cos phi plus zeta x times of sin phi. So this is for inductance. Similarly, capacitance ಗೆ ಏನಂತ ತಗೋಬೇಕು, it is zeta r times of cos phi minus zeta x times of sin phi. Important. Look at the things carefully. Now, how can you define phi? Phi ಅನ್ನೋದು ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಬರುತ್ತೆ? It is tan inverse of XL divided by R. XL divided by R. Similarly, in this one also, phi is given by tan inverse of XC divided by R. Very, very important. XC divided by R. Very, very important. Now, based on this, what are the type of regulation you are going to get? The types of regulation is, you may get positive. Yes, you will be getting positive. Are you going to get 0? No. Are you going to get negative? Yes, you will not be getting a negative. You will not be getting a negative. Similarly, in this capacitance ಅಥವಾ ಲೀಡಿಂಗ್ಗೆ ಏನಂತ ಬರುತ್ತೆ, ರೆಗ್ಯುಲೇಷನ್. ಇಫ್ ಐ ಆಮ್ ಸ್ಪೀಕಿಂಗ್, ಇಫ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ರೆಗ್ಯುಲೇಷನ್ ಏನಂತ ಬರುತ್ತೆ. ಸೊ ರೆಗ್ಯುಲೇಷನ್ ಕ್ಯಾನ್ ಬಿ ಪಾಸಿಟಿವ್ ಆರ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ನೆಗೆಟಿವ್, it can be 0 also. In this case, regulation is tending to a maximum value. It may tend to a maximum value. But look at the things. In this case, regulation can't be a maximum value. Regulation can't be a maximum value. This is one thing what you have to remember. This is one thing what you have to remember. Next, based on this power factor variation, we can derive some conclusion. Right? Now, look at the things carefully. This one is where when power factor equals to 0. This is when power factor is tending to a maximum value. Right? What is this value? This value is referred as, so look at the things. When power factor equals to 1, when power factor equals to 0, these things are very, very important. When power factor equals to 1, is it a leading network? Is it a lagging network? This idea, if you are having more than enough. Right? So this is a zeta x divided by zeta z. Now tell me, what is the magnetizing current you are going to get? So the magnetizing current Im. So Im is referred as magnetizing current, which is proportional to flux, which is proportional to V by F. Now, in order to get familiar with the things, let us solve some problems. So ಅವ್ರು ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, a 220 volts cross 440 volts, 50 hertz is supplied from a 40 hertz. Right? So what should be the voltage at source such that flux remains same and what is the output voltage ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. Right? Now ಇದರಲ್ಲಿ ಏನಂತ ತಗೊಂಡಿದ್ದಾರೆ, phi equals to V divided by F ಅಂತ ತಗೊಂಡಿದ್ದಾರೆ. Right? So if you are going to consider two cases, in first case it is operating at 50 hertz and the voltage is 220 volts. ಇದರಲ್ಲಿ ನಂಗೆ ಏನು ಫ್ಲಕ್ಸ್ ಜನ್ರೇಟ್ ಆಗುತ್ತೋ ರೈಟ್, ಇಟ್ ಈಸ್ ಸೇಮ್ ಆ್ಯಸ್ 40 Hz. ಎರಡರಲ್ಲೂ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಫ್ಲಕ್ಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ರಿಮೈನ್ ದ ಸೇಮ್. Now look at the things. Phi equals to V divided by F. Phi is constant. So we are going to take a V11 divided by F11. This is for first one. For the next case, we are going to take V12 divided by F12. What is V11? 220 divided by, what is F11? F11 is to 50, which is equals to V12, we don't know, divided by F12 yesterday 40. F12 is how much? It is 40. Now what is the value of V12? It is 220 into 40 divided by 5 you are going to get. 220 into 40 divided by 50 you are going to get, right? So upon solving this, what is the expression you are going to get, or what is the value you are going to get? So it is 220 into 40 divided by 50. ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ 176 you are going to get. V12 which is equals to 176 volts, right? Now you please consider V2 equals to, say suppose V1, 2 times of V1 you are going to get, right? Why it is 2 times of V1? Look at the things. It is 220 over here, 440 over here. So nodi, here one transformer is there, here one transformer is there. The ratio you have taken is 1:2. The ratio what you are taking with respect to the transformers is 1:2. 1:2, right? 1:2. Here, what is the input voltage you have applied? 220 volts. What is the output voltage? 440 volts. Similarly, look at the things carefully. What is V12? 176. What is the output voltage? In this also, turns ratio will be the same. What is 176 divided by 2? So it will be 352 volts. Very important. Next question. A 220 volts cross 440 volts transformer is powered by, so you take this one as 220 volts, is powered by 220 volts. Calculate the secondary voltage, or calculate the output voltage and flux density inside the core. If area of cross section of core is 40 centimeter square, and primary winding is 0. We know that V2 divided by V1 which is equals to N2 divided by N1, right? What is the value of V2? V2 is given by V1 into N2 divided by N1, which is equals to. Now what is the value of V1 you are going to get? It is 220 into 440 divided by 220. What is the value of V2 you are going to get? V2 equals to 440 volts you are going to get. Right? Now what is the value of N2? Important. What is the value of N2? How you are going to find the value of N2? Very important. Right? Now what is the value of V1 you are going to get? 220, right? 220 you got. So it is double you are going to get. So N2 is almost twice. So what is the value of V2 you are going to get? V2 equals to 440 I am going to get, right? V2 equals to 440 I am going to get. Now with the help of V2 which is given by N2 into Bm into A times of F into 4.44. So what is the value of V2 you are going to get? So upon solving, what is the value you are going to get means it is 1.25. 1.25 Weber per meter square. It is ಎಷ್ಟು ಬರುತ್ತೆ 1.25 Weber per meter square. Very important, very important. Next question, what they have given is a 250 kilovolt amperes 500 volts slash 100 volt 50 hertz single phase transformer has full load copper loss of 1000 watts, full load core loss of 800 watts. So what they are asking is you have to calculate the core loss, copper loss and the total loss at quarter load, half load and full load. So let us talk about at quarter load, at half load, at full load, at full load. Now look at the things carefully, You talk about this core loss. This core loss at any given moment of load, it is a fixed quantity. Right? So I am going to retain as it is. Now you talk about the copper loss. You talk about the copper loss, which is equals to x square times of PCU. Now tell me what was the initial power? Nothing but at full load, what was the power that is being dissipated, which is equals to 1000 watts, right? So similarly at full load, what is the expression you are going to get? PCU of x, which is equals to x square, nothing but 1 square times of PCU. What is this value? Right? So when it is at full load, what is the value? So it is same as 1000 watts only. Similarly, you talk about at half load. So what is this value you are going to get? PCU of x, which is equals to x square times of PCU. See, it is half. Half means what? Half square you are going to get 1 by 4 into 1000 watts. What is the value you are going to get? 250 watts. Similarly at full load. Okay, so this one I have calculated at full load. So this is at full load. So only I have taken x equals to 1. So here you please take this one as quarter load. In the case of quarter load, what is the expression you are going to get? PCU of x, which is equals to 1 by 4 square is what? 1 by 16 times of PCU, nothing but what? 1000 you are going to get. So 1000 divided by 16, how much you are going to get? 1000 divided by 16, how much you are going to get? So it is 62.5. Very important. At quarter load, you are going to get just 62.5 watts. You are going to get 62.5 watts. Say suppose if they are asking 75% load. Say suppose if they are asking 75% of the load, you have to consider, right? So at that time what you have to do is 1000 multiplied by 75 square 0.75 into 0.75 finished. 562.5 you are going to get. So in this case it is 562.5 watts you are going to get. Very important, right? Similarly, let us solve the next question, right? Another 2 or 3 questions are there, that's it. 100 kilovolt ampere 500 volts slash 200 volts 50 hertz single phase transformer has a copper loss of 200 watts. At half load. At full load they have not given, and core loss of 600 watts at half load. Calculate kVA described by the load at maximum efficiency, right? In the previous question we have did one small mistake. We didn't calculate the total power, right? Total power na heng calculate madbodu, which is equals to PC plus PCU of x. ಎಷ್ಟು ಬರುತ್ತೆ 1800 watts you are going to get. Similarly in this one, what is the value? 1050 watts you are going to get. 1050 watts you are going to get. In the case of quarter load, how much you are going to get? It is 62.5 plus 800. So it is 862.5. Similarly, in this one also it is 1362.5. So this is the total power you are going to get. This is the total power you are going to get, right? Units be very much familiar. It is watts, right? Next, let us solve one question. 100 kVA, 500 volt slash 250 volts, 50 hertz single phase supply they have given, right? As a copper loss of 200 watts at half load and core loss which is equals to 600 watts at half load. Calculate the kVA delivered at the load in order to achieve maximum efficiency they are asking, right? We know that PCU of X which is equals to X square times of PCU, right? So what is this value? They have given this value as a 200 which is equals to, what is the value of X square at half load? They are asking 0.5 square times of PCU. So what is the value of copper loss you are going to get? What is the value of copper loss you are going to get? 800 watts you are going to get. 800 watts you are going to get, right? But look at the iron loss. Look at the iron loss. It is independent of load, right? It is independent of load. So the iron loss you are going to get which is 600 watts, which is 600 watts. Now you try to calculate the efficiency. So in order to calculate the efficiency, you are in need of what? Formula. So maximum efficiency is given by Xm which is equals to under root of PC divided by PCU, which is equals to how much you are going to get? 0.866. 0.866 you are going to get. Very important, very important, right? So Xm which is equals to under root of PC divided by PCM. PC divided by. Now let us talk about the kVA that is being delivered, right? ಎಷ್ಟು delivered ಆಗಿದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಕೇಳಿದಾಗೆ how we are going to solve. This is X times of VA into cos phi which is equals to, what is the value of X you are going to get? What is the value of X you are going to get? 0.866 into, what is the value of VA you are going to get, right? What is the value of VA? They have given 100 kVA. So write it as 100. So the maximum that kVA is developed is 86.6 only. 86.6 only. Next question. 100 kilovolt ampere, 1000 volt slash 400 volt, 50 hertz single phase transformer has an efficiency of 98% at half load and full load. Efficiency same irutte, and you have to consider unity power factor. Then you have to find what is the core loss and what is the copper loss. So efficiency, what is the formula? X times of VA into cos phi whole divided by X times of VA into cos phi plus PC plus X square times of PCU plus X square times of PCU. This is the formula for efficiency. Now substitute the value 0.98 which is equals to, first case let me take half load. Half load nalli X value ಏನು ಬರುತ್ತೆ? 0.5 into, what is volt ampere? ಎಷ್ಟು? 100 into 10 power 3 into cos phi ಏನಂತ ತಗೋಬೇಕು? 1 ಅಂತ ತಗೋಬೇಕು, whole divided by 0.5 into 100 into 10 power 3 into 1 plus, what is the value of PC? We don't know, plus what is the value of X? 0.5 square which is 0.25 you are going to get into PCU you are going to get. So what is the value you are going to get? So ಈ ಥರ ಕ್ವಶನ್ಸ್ ಏನಾದರೂ ಕೊಟ್ಟಿದ್ರೆ ನೀವು ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಾ? ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ವಿತ್ ಯು ಇಟ್ ಈಸ್ ವೆಲ್ ಆ್ಯಂಡ್ ಗುಡ್. ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇಟ್ ಈಸ್ 0.5 into 100 is what? 50 into 10 power 3. 50 into 10 power 3 nothing but 50,000 divided by 0.98. ಎಷ್ಟು ಬಂತು? 51020 ಮೈನಸ್ ಏನು ಮಾಡಬೇಕು? 50 into 10 power 3 nothing but 50,000 you are going to do. So PC plus 0.25 times of PCU, which is equals to ಏನಂತ ಬಂದಿದೆ 1020.4. Take this as equation 1. Mark this as equation 1. Second, from star at full load. From star at full load. Full load ಅಂದರೆ ಏನಂತ ಬರಬೇಕು, x equals to 1 ಅಂತ ತಗೋಬೇಕು. Efficiency is the same 0.98, which is equals to 100 into 10 power 3 into cos phi value is 1 whole divided by 1 into 100 into 10 power 3 into 1 plus core loss ಏನು ಗೊತ್ತಿಲ್ಲ plus x square ಏನು 1 square is 1 only, right, into P copper loss. Right. What is the expression you are going to get? 100 into 10 power 3 divided by 0.98. ಎಷ್ಟಂತ ಬಂತು 10204 minus what is the value you are going to get? Minus 100 into 10 power 3. 100 into 10 power 3. So what is the value you are going to get? PC plus PCU, which is equals to 2040.81. 2040.81. Take this one as equation 1, right? Now PC plus 0.25 times of PCU, which is equals to 1020.4. Then next equation is PC plus PCU, which is equals to 2040.81. Now look at the things carefully. See, simultaneous equation is there. You can solve PC and you will be getting PCU, right? Now let me change the sign. So now I am finding PCU value. So PC and PC is going to get cancelled, minus 0.75 times of PCU, which is equals to 2040.81 minus 1020.4. So what is the value you are going to get? It is minus of 1020.41. What is the value of copper loss you are going to get? Right? The value of copper loss, which is 1360.54. So many watts you are going to get. So this is the loss. What you are going to incur. Now you know what is the value of copper loss. Can you find what is the value of core loss? ಕಂಡುಹಿಡಿಯಬಹುದು. Core loss can be found out. Either make use of equation 1 or you just make use of equation 2. Say suppose if I am making use of equation 2, 2040.81 minus 1360.54 you are going to get, right? So this one, if I am subtracting, what is the value I am going to get? So the value is 680. The core loss is 680.26. So how much is the loss that is being incurred? It is 680. So this is how we are going to solve the core loss and copper loss. But simultaneously, if they are asking with respect to this x value, if they are asking, or efficiency if they are asking, right? So at under root of PC divided by PCU you are going to get. So efficiency, if you want to find, one more way, which is not exactly correct, which is equals to under root of 680.26 divided by 1360.54. Roughly what I can tell, under root of 0.5. Roughly what I am going to get, under root of 0.5 I am going to get. Under root of 0.5 is how much? 0.7071. See, transformers ಇದ್ರೂ ನಾವು ಯಾಕೆ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ನ ನಾವು ಪ್ರಿಫರ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಒನ್ ಈಸ್ ಈಲ್ಡ್ ಈಸ್ ಮೋರ್, ನಥಿಂಗ್ ಬಟ್ ಬಿಕಾಸ್ ಆಫ್ ಎಫಿಷಿಯನ್ಸಿ. ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ನಲ್ಲಿ ನಾನು ನಿಮಗೆ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಟೀಚ್ ಮಾಡಿದ್ದೀನಿ, ರೈಟ್? ಸೊ ಇನ್ ದಿಸ್ ಥಿಂಗ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಸ್ಟೆಪ್ ಅಪ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಸ್ಟೆಪ್ ಡೌನ್, ರೈಟ್? ಸೊ in this also you will be having step down auto transformer and step up auto transformer. Step down auto transformer, step up transformer hinge represent madodu. Now first let us talk about step up auto transformer. let us talk about step up auto transformer. Main thing is polarity is important. Polarity is important, right? Without that polarity, it is very much difficult. Next, say suppose this current is 1100 amperes and the voltage is 2000 volts over here, right? So polarities, look at the things I am going to give like this. That means what? Current is from this, current is from this, right? So current direction it is going to talk, it is going to speak with respect to current duration. Now let us consider the downward current is 100 amps. Now let us consider upside how much it is flowing at 2000, right? So in terms of amperes also you want to write, you write, or in terms of voltage also if you want to define, you can define. Assume that upper part is 2000, sorry, upper part is, say suppose you are getting 200 volts. Upper part you are going to get 200 volts, right? Lower part how much you are having? Lower part how much you are having? Already you are having 2000. So ಏನು ಬರುತ್ತೆ net voltage over here? It is 2200 volts. 2200 volts. ಏನಾಗ್ತಾ ಇದೆ? ಸ್ಟೆಪ್ ಅಪ್ ಆಗ್ತಾ ಇದೆ. KVA ರೇಟಿಂಗ್ ಏನು ಬರುತ್ತೆ? 2200 into 1000 amperes into 1000 amperes, right? So what is the rating you are going to get? What is the rating you are going to get? 2200 KVA, this much of huge KVA you are going to get. Look at the previous problems. ಏನು ಬರ್ತಾ ಇದೆ? 100 KVA, 100 KVA, 250 KVA ಅಂತಾನೆ ಬರ್ತಾ ಇದೆ. ಬಟ್ ದ ಮೊಮೆಂಟ್ ನಾನೇನಾದರೂ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ KVA rating as more, right? So this is with respect to step up. Now let us talk about step down also. Let us talk about step down also, right? Step up ಮತ್ತು step down ಅನ್ನೋದು ಯಾವ್ದು ಡಿಸೈಡ್ ಮಾಡುತ್ತೆ? Your polarity is the one which is going to decide. Your polarity is the one which is going to decide, right? Let me consider here I am applying 2000 volts. Here I am applying 2000 volts. Because of this polarity, right? Here I am going to get minus 200 volts. Here 2000 volts is there. What is the net voltage? What is the net voltage? 1800 volts you are going to get. 1800 volts you are going to get. Is it not step down? Yes, it is a step down. It is a step down. It is a step down, right? What is the rating? 1800 KVA you are going to get, right? In the case of step down also you are going to get some good value of KVA, right? Now let us talk about advantages ಮತ್ತು disadvantages ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. What are the advantages of using auto transformers ಅಂತ ಕೇಳಿದ್ರೆ you should have a clear cut idea. Next, first advantage ಏನು? Power rating of a transformer is improved. ಹೆಂಗೆ ಹೇಳೋಕ್ಕಾಗುತ್ತೆ? Look at the values. 2200 KVA, ಬಟ್ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ನೋಡಿ, ಇನ್ನಿನ ಕ್ವಶನ್ಸ್ ಎಲ್ಲ 100 KVA, 250 KVA ಬರೀ ಇದೇ ವ್ಯಾಲ್ಯೂಸ್ನೇ ಇತ್ತು, ರೈಟ್? ಬಟ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ current is more, voltage is more, KVA rating is more, right? Power rating of the transformer increases. Power rating of the transformer increases. Very, very important, right? The next advantage is, right? So you will be getting efficiency improves. See, most of the persons they will be telling power rating of the transformer is increasing. What do you mean by power rating? Now look at the things. You will be having less amount of iron and copper loss. You will be having less amount of iron loss and copper loss. Iron loss and copper loss. Very, very important. Efficiency is getting improved. Then regulation improves. Improves ಅಂದರೆ ಏನು? ಜಾಸ್ತಿ ಆಗಬಾರ್ದು. ವಿ ನೋ ಲೋಡ್ ಮೈನಸ್ ವಿ ಫುಲ್ ಲೋಡ್ ಡಿವೈಡೆಡ್ ಬೈ ವಿ ಫುಲ್ ಲೋಡ್ ಅಂದರೆ ಏನಂತ ಬರಬೇಕು? ರೆಗ್ಯುಲೇಷನ್ ಅನ್ನೋದು ಕಡಿಮೆ ಬರಬೇಕು. ವೆರಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ರೆಗ್ಯುಲೇಷನ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಗುಡ್ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ ಏನು? ಕಡಿಮೆ ಇರಬೇಕು, ರೈಟ್? ನೆಕ್ಸ್ಟ್, ವಾಟ್ ಆರ್ ದ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಆಫ್ ಯೂಸಿಂಗ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್? ಯಾರಾದರೂ ಹೇಳೋಕ್ಕಾಗುತ್ತಾ? ವಾಟ್ ಆರ್ ದ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಆಫ್ ಯೂಸಿಂಗ್ ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್? The first disadvantage is there will be no longer electrical isolation. there will be no longer electrical isolation. It has lost its electrical isolation. Very important, very important, right? Next, ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ ಪ್ರೀವಿಯಸ್ ಇಯರ್ನಲ್ಲಿ. ಏನಂತ ಕೇಳಿದ್ದಾರೆ? ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ಪ್ಯಾರಲಲ್ ಆಪರೇಷನ್, ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ಪ್ಯಾರಲಲ್ ಆಪರೇಷನ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ಪ್ಯಾರಲಲ್ ಆಪರೇಷನ್ಸ್. ವಾಟ್ ಆರ್ ದ ಕಂಡೀಷನ್ಸ್ ದಟ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಮೀಟ್, that it has to meet, right? First case ಏನಿರಬೇಕು? polarities should be same, polarities should be same ಅಥವಾ it should be an essential, right? Next, R value should be same, R should be same, R should be same. Next one is there, that is x by r ratio should be the same, x by r ratio should be same, x by r ratio should be same, right? At this time, at this moment, you can connect two transformers in parallel. Normal transformers ನೀವೇನಾದರೂ parallel ಆಗಿ ಏನಾದರೂ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ these conditions should be satisfied. Polarity should be the same, R should be same, x by r ratio should be the same, x by r ratio should be the same. Efficiency ಏನು ಬೇಕಾದ್ರೆ ಆಗಿರ್ಬೋದು, efficiency ಏನು ಬೇಕಾದ್ರೆ ಆಗಿರ್ಬೋದು, right? Least for that, right? So ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲಿ ಏನೇನು ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀರಿ? ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ ಮತ್ತು ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ಅದಲ್ಲದೆ ವಿ ಹ್ಯಾವ್ ಸಾಲ್ವ್ ಸಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ದೆನ್ ವಾಟ್ ಈಸ್ ದ ಕನ್ಕ್ಲೂಷನ್ ವಿ ಹ್ಯಾವ್ ಡ್ರಾನ್? In the case of varying load, core loss is always constant ಅಂತ ಕಂಡುಹಿಡಿತೀರಿ, right? Core loss is always constant, right? KVA rating is improved in which case? In which case KVA rating is improved? In auto transformers. In auto transformers KVA rating is improved. ಅದೇ ಇದರಲ್ಲಿ ನೋಡಿ, ಈ ಕೇಸ್ನಲ್ಲಿ ಏನಂತ ಬರುತ್ತೆ? 1800 KVA, right? ಸ್ಟೆಪ್ ಅಪ್ಪಲ್ಲಿ 2200 KVA ಬಂದಿದೆ, ಸ್ಟೆಪ್ ಡೌನಲ್ಲಿ 1800 KVA ಬಂದಿದೆ, right? So the advantages of using auto transformer is power rating of the transformer increases, nothing but less amount of iron and copper losses will be there, right? Then efficiency is increasing, efficiency increases, regulation improves, nothing but what? Regulation is going to decrease. What are the disadvantages of using auto transformer? No longer an electrical isolation, no longer an electrical isolation. ನೋಡಿ, ಈ ಕ್ವಶನ್ನ 2019 ಕೇಳಿದರೆ, ಕಂಡೀಷನ್ ಫಾರ್ ಪ್ಯಾರಲಲ್ ಆಪರೇಷನ್ ಇನ್ ಅ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಆರ್ ಆಫ್ 2 ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಅಂತ ಕೇಳ್ತಾರೆ, ರೈಟ್? ಆಫ್ 2 ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್. ಸೊ ಆ ಥರ ಏನಾದರೂ ಕೇಳಿದಾಗೆ ಯು ಶುಡ್ ಬಿ ಇನ್ ಎ ಪೊಸಿಷನ್ ಟು ಆನ್ಸರ್, ರೈಟ್? ಫಸ್ಟ್ ಒನ್ ಈಸ್ ಅ ಪೊಲಾರಿಟೀಸ್ ಶುಡ್ ಬಿ ದ ಸೇಮ್. ನೆಕ್ಸ್ಟ್, ಆರ್ ಶುಡ್ ಬಿ ಸೇಮ್ ಆ್ಯಂಡ್ ಎಕ್ಸ್ ಬೈ ಆರ್ ರೇಷಿಯೋ ಶುಡ್ ಬಿ ದ ಸೇಮ್. ಎಫಿಷಿಯನ್ಸಿ ಏನು ಬೇಕಾದಾಗಿರ್ಬೋದು, ಇಂಪಿಡೆನ್ಸ್ ಆಲ್ಸೋ ಡಸಂಟ್ ಮ್ಯಾಟರ್, ಬಟ್ ಎಕ್ಸ್ ಬೈ ಆರ್ ರೇಷಿಯೋ ದ್ಯಾಟ್ ಒನ್ ಮ್ಯಾಟರ್ಸ್ ಅ ಲಾಟ್, ರೈಟ್? ಸೊ ಇವತ್ತಿನ ಈ ವಿಡಿಯೋದಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದೀನಿ, ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದೀನಿ. ಮೇಡ್ ಅ ಕಂಪ್ಯಾರಿಸನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಮತ್ತು ಆಟೋ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್, ಮತ್ತು ಐ ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್, ರೆಗ್ಯುಲೇಷನ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದೀನಿ. ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಆಫ್ ದ ವಿಡಿಯೋ we shall discuss with respect to DC machines and construction part of transformers, right? So ಈ ವಿಡಿಯೋ ನಿಮಗೆ ಏನಾದರೂ ಇಷ್ಟವಾಗಿದ್ದರೆ ಈ ವಿಡಿಯೋಗೆ ಒಂದು ಲೈಕ್ ಕೊಡಿ, ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಕನ್ನಡ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡೋದನ್ನು ಮರಿಬೇಡಿ ಅಂತ ಹೇಳ್ತಾ ಈ ವಿಡಿಯೋ ಸೆಷನ್ನ ಮುಗಿಸ್ತಾ ಇದ್ದೀನಿ ಫ್ರೆಂಡ್ಸ್. ಥ್ಯಾಂಕ್ ಯು ಫ್ರೆಂಡ್ಸ್, ಧನ್ಯವಾದಗಳು. ಸಿಗೋಣ ಮುಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ.